Hi everyone, this is the gas walkthrough for March 29th. I'm Philip Newman, and I'm solving Me, Myself, and I by Bill Murphy. This is a non-consecutive Sudoku, so we have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, adjacent cells must not contain consecutive digits. So there's a 5 here. We can't put a 4 here, because 4 and 5 are consecutive. Those are the rules. And this is a global constraint that can be quite hard. You can have very minimal puzzles, very few given digits, and have a unique solution. And those grids kind of have some spooky properties. Fortunately, Bill has given us a lot of given digits. And you might be drawn to the top 2 rows with all the givens here, or the bottom 2 rows. I believe when I test solved this, I did a lot of pencil marking there. The place to start is actually right in the middle, and we're going to focus on that 5. What can go in these 2 cells? We can't put a 2, a 3, a 5, a 7, or an 8 in these cells. And we also can't put 4 and 6 because they are consecutive with 5. So the only thing that can go in these cells is 1 and 9. Now, we still need a 3 in this row. We could have done this from the start without worrying about the 1 and 9. I just thought that was interesting. Where does 3 go? 3 can't go here, and it can't go next to 2, so the only place for 3 is here. Where can 4 go? 4 can't go in these cells, so it goes here. 7 can't go in this cell, so it goes here, and finally 6 here. And I apologize if I sound congested today. It's because I am congested today. In this column, we still need 1, 2, 8, and 9. We already have the 1 and 9 here. So this has to be 2, 8. 2 can't go next to 3. So they go in that order. And now 1 can't go next to 2. These are 4 and 6. We know the order from the givens. Now in this column, we need 7, 8, and 9. This cell sees an 8 and a 9, so it's 7. And 8 can't go next to 7. So this is 9, and this is 8. In this column, we need 1, 2, 3. We have a 1 and a 2. 2 can't go next to the 3. And that resolves that column. Now we still need an 8 in this row. There's an 8 here. So 8 goes there. These are 5 and 9. 9 can't go next to the 8. So that's 5, 9. And 2 is the last digit in the box. And then these are 1 and 5. The 1 can't go next to the 2. That resolves that box. All right, let's look at this column. These are from 4, 5, 7, and 8, and there's a 5 and an 8 here. So this is 4, 7 in this order because of this 7. These are 5, 8 in this order because of this 8. And I bet we can do the same thing here. We need 2, 3, 5, and 6. 2 and 5 are here, and the 3 here means this is 6 and 3. And then the 2 here, 5 and 2. And now we need 3, 6, 9 in this box. The 6 can't go here, and it also can't go next to the 5. So this is our 6. This is our 9 because of the 3. That's 3. These are 1, 4, and 7. The 7 can't go here or here because of the 6. So it goes here. 4 goes here. 1 goes here. These are also 1, 4, and 7. You might be noticing a pattern in the grid. We'll look at that at the end. But this is 4, 7, and 1 because of these digits. We don't even have to worry about the non-consecutive here. These are 5 and 6, and we have a 4 there, so that can't be 5. That's 6, 5. These are 8 and 9, and don't know the order of those yet. These are 2 and 3. We do know those from this 3. All right, these are going to be 3, 6, and 9. And we know the order from those digits. Here we have 7 and 8. That 8 is going to look down 8 and 9. The 9 looks up for 1 and 9. These are 1 and 2. And finally 5 and 4. And that is how you solve Me, Myself, and I. Now, if we look at the finished grid here, you might notice that in the columns, we have the same triples all across the grid. And so 1, 4, 7 here, we also have 2, 5, 8 throughout the grid, and 3, 6, 9 if you look at your keypad, you might notice those appearing. This is something called fully roped. So roping is when you have the same triples in the 3 columns of a stack, these 3 boxes, or the same thing in the rows. So here we have 1, 2, 6. If you ever have 2 triples that are the same like this, 1, 2, 6, 1, 2, 6, you know the third one is going to be the same. And you know that the other ones are also going to be repeated like this. So in this direction, we only have 3 different triples. We have roping in the other direction, but the triples are different, but just a little different. You'll see a lot of that kind of structure in very constrained global constraints. So it's not required for non-consecutive, but the way Bill set this puzzle, it appears. So I hope you found that enjoyable. Let us know in the comments how you did, and I will see you next time.